can do all sorts of demos just with this lump of copper. That's all it is, just a lump of copper. It's actually copper telluride. Near enough, it's just copper.
That would be an expensive piece of kit, that one. So,
Came out of the buzz bars of a nuclear submarine. However, I think you've all seen this done before at some point. You just pull that out there, and of course Lenz's law comes into play. Okay, it's really kind of cool. And conversely, if you just put it at an angle and try to swing it through here, you get that effect. Then you tell the kids, okay, well, it's obviously not magnetic. It doesn't want to join up, does it? So what happens if I pull the copper away? I stopped it from swinging that way because that's iron. I don't want it attracting that way. So there's all sorts of tricks and gadgets you can do with that one. Yeah. And one of my personal favourites involves what I call the beast. And the beast is here. I talked to them about elevators and how when elevators were originally invented, people wouldn't ride them because they thought, well, it's just hanging by a single cable, and what guarantee have we got that that cable's not going to snap and we're just going to fall to our deaths? And people were generally terrified in the 19th century that that would occur, or late 18th century, early 19th century. And so they had to come up with a safety system that was foolproof and then prove to people that it worked. And here's what they came up with. The same thing that stops a roller coaster is a lump of copper and a great big kick-ass neodymium magnet. You get the kids to talk about energy change and whether you can change energy from one form to another. You get them to say, well, what happens when I drop this big piece of metal onto another big piece of metal, and watch them go, ooh, when that happens. Cool, huh? Can you get the strongest kid in the room and say, okay, I want you to drag that from one side to the other as fast as you can. Look, it's easy, I can do it with my little finger, right? But then you get them to try and do it from speed as fast as they can, and that actually hurt. And the harder and faster you try to do it, of course, the greater current you're producing, the greater force you're producing against the motion you're trying to create. How cool is that? And it goes down pretty well.
Does a normal magnet work?
Sorry?
Does one of your baby neodymiums do the same?
Baby neodymium, like one of this one.
Yeah.
Okay, let's try it, shall we? Gotta be careful with that guy. Be really careful with this guy because this guy's a beast. That's why we have that lump of copper right there. So let's try that. No. It does, you can, if you come and feel it, I'll just put this guy out of the way. If you come and feel it, you'll feel that there is an effect. And what I like to do is I like to do this. Lift it up like that. And then I like to just roll it. You get them to explain that.
and it'll never roll off, will it either?
That one's got actually a chip out of it, so normally it should follow an S-shape back, normally down.
Your other one up there does.
Yeah, there we go. Follows an S-shape like the
You've
one
got
that,
your down the copper there.
yeah, it's a bit, this one's got a bit of a chip in it. I've been using it just indiscriminately. There we go. Oh yeah, there's a little lump sticking out. Ooh, not when I got that in my hand. There we go. There we go. But it turns.
Go down towards the side.
Yeah, that's right. Yeah, just like that.
You tilted it a bit, looks better.
Hmm?
You tilted slightly at the very beginning, that's better, I think.
Oh yeah, just like that.
So,
There you go.
All you do is pull it back up
Oh yeah, that's right.
and it changes direction.
Changes direction,
As
yeah,
it
there
comes towards the side, it comes round your back.
If you get the big one, you just pass me that nice one.
Pull a whole lot out from underneath.
We'll go through the S pattern.
Stuck there.
So you go through the S pattern there?
Dropped the other thing.
There it is.
Yeah.
Yeah. Just at the top here, if I amplify it a little bit, going through the S pattern there before it decides to go one way or the other.
Bigger current one side than the other, therefore force is bigger on one side
There we go. Cool.
than the other a bit. And
So that's
therefore it
that. That's
turns
what
it.
we